Hi, welcome to supplementary video for lesson 2D on composite functions. I'll just go through a couple of examples here just to clarify the previous lesson that we had seen in class. Here is a function f of x, and I will say f of x equals x squared minus 3. And I just want to evaluate this function f of x at a few constants, a couple values of x. So I will evaluate f of x at x equals 2. So all I do is substitute in 2 in for x, and then do some calculating. So 2 squared minus 3 gives me 4 minus 3, which is 1. Let's substitute in a different value. Let's substitute in negative 3 now. So I'm going to evaluate function f of x at x equals negative 3. So I substitute negative 3 in for x. So I get negative 3 squared minus 3, which gives negative 3 squared is 9, minus 3 gives me 6. So I can do the same thing as substituting in constants, but I can also substitute in variables. So let's substitute in substitute in a in for the equation, in for x, and so we get a squared minus 3, which gives me a squared minus 3. Okay, same principle, just substituting the value in for x. So in this case, we're substituting a in for x, and we get a squared minus 3. We can also substitute in things a little bit more challenging, like a plus 2, for example. And same sort of idea applies, just a plus 2 goes in for x, gets substituted in where x is, and then we can just calculate it as normal, or simplify out as we would do so from past years' experience. So a plus 2 all squared is the same as a plus 2 times a plus 2. We'll use the distributive property to expand a times a, and a times 2, and 2 times a, and 2 times 2. And then when we expand that out, we get a squared plus, and then a times 2 is 2a, 2 times a is 2a, and add those together, we get 4a plus 4, which is from 2 times 2, and minus 3, and then we get a squared plus 4a plus 1. Okay, so all that's fine and good. What if we were to find another variable, another function, to find another function g of x as 2x plus 4? And we can do the same kind of thing. We can evaluate function g at negative 1. So the same idea, we just substitute negative 1 in for x. 2 times negative 1 is negative 2, plus 4 gives us 2. Same sort of idea. Instead of going to another constant, I'll substitute in a variable. We can substitute in perhaps variable d. And same idea, just substitute d in for x. And so we get 2d plus 4. And if we really wanted to get wild and crazy, we can substitute in more than just one variable. We can substitute in a little binomial, a little polynomial expression here. Substitute d minus 4 in for x, so we get 2 d minus 4 plus 4, and so we use the distributive property again, 2 times d and 2 times negative 4, so we get 2d minus 8 plus 4, and that gives us 2d minus 4. Now, let's up the ante a little bit. And what if, instead of a plus 2, what if I were to substitute 2x in for f of x? Remember that f of x is x squared minus 3. So I'll substitute in 2x. So the 2x goes in for x. So same kind of idea as what we did up here with the a plus 2. And now I'll simplify. 4x squared minus 3. And that's as far as that goes. And if I take this one step further, and I'll substitute now 2x plus 4 in for x. So where we see the x, we substitute in the whole 2x plus 4, just like we did with that other binomial. Now something special about 2x plus 4 is that's our function g of x. So g of x equals 2x plus 4. So what we're actually doing is we are substituting in g of x into the function f. And so then if we were to expand this out, we would get 4x squared, and then 2 times 4 plus 2 times 4 gives us 16x. 4 times 4 is 16, minus 3, and that gives us 4x squared plus 16x plus 16, plus 13. Okay. Now notice that 2x plus 4 is actually g of x. Okay, so we're just substituting in a function into another function. And another way of writing that is f composite g of x. Okay, so these two things, f of g of x and f composite g of x, those are exactly the same thing, just different notation. Okay, so we've said in the past the input and the output. I guess the input in this case would be g of x, which is 2x plus 4. We input that into function f, and then the output of f, which is f of g of x, then gives us 4x squared plus 16x plus 13. Now we can do the same kind of thing with g. Suppose we substitute in x squared in for g, or into g, and then because the function g is 2x plus 4, we're just going to put the x squared into the x, and we get 2x squared plus 4. And of course, one more step. X squared minus 3 gets substituted in. So we get 2 times x squared minus 3 plus 4. But what that actually is, of course, that x squared minus 3 is just f of x. And I can expand that in to x squared minus 6 plus 4 gives me 2x squared minus 2. So this x squared minus 3 is nothing more than just f of x. So I've now substituted f of x into g of x, which is the same as f composite f of x, which is f follows g of x, which is just the input for g. The input for g is actually f. So the input for the function g of x is the entire function f of x, which is x squared minus 3. And then the output is g of f of x, or g composite f of x, which is 2x squared minus 2. Okay, so I hope that has cleared things up a little bit. If so, that's great. If not, please come back to class and ask me some more questions. So thank you for your attention, and we'll see you in class.